Welcome to the first in our series about building AI into the fabric of your organization. The series is really focused about not just thinking of AI in isolation within your business, but looking at how you can apply it around everything you do and into the future construct of your organization. I'm delighted today to be joined by Daniel Hulme, who I've known for 20 years. Welcome, Daniel.
Yeah, we go way back.
Recently rated 25 in the world in AI, so amazing achievement, so well done for that. It's quite amazing to see the accomplishments over the years and what you've done. A double unicorn investor with Satalia and Faculty.ai, so thanks so much for joining us today.
It's a pleasure. Yeah, it should be good fun.
So it's, I guess when we talk about building AI into the fabric of the organization, the first things I guess everybody's saying is, they're hearing about it in everything that they're doing. What would be the first bit of advice you would give an organization just in relation to setting the foundations around starting that within their business, if they haven't already?
So, if a genie gives you one wish, you ask for more wishes. And so the one piece of advice I usually give people is go and get the right advice. Surround yourself by people that really deeply understand these technologies, have a proven track record of placing the right bets. Organizations are being sold left, right, and center AI technologies, but it's very hard to navigate what's real, what's not, what's going to be sustainable, et cetera, et cetera. So surround yourself by people that really deeply know what they're talking about. Educate yourself as a leader to make sure that you're placing the right bets.
And do you think that it would make sense for organizations to focus on that partner model, as you described, finding the right people to do that, or bringing talent into the organization? Because there must be a challenge around the sustainability of talent within organizations with the boom of AI.
Yeah, so you remember back in the day a concept called shadow IT, people using technology and you don't really know who's using it and how they're using it. And now that term is being used for AI, so the shadow AI. And the reality is there isn't really one solution. I think there's a sort of tripart strategy that you need to adopt as an organization to make sure that you're thriving in the world of AI. The first is enabling your employees to innovate at the edge. So how can you make sure that they are using AI or building agents to help them make their jobs more efficient, more effective? So in WPP, over the past 3 years, we've been agentifying the organization, helping people build AIs at the edge, and we've got something ridiculous like 70,000 agents operating across the business. So that's the first thing. Allow people to innovate at the edge, obviously in a safe and responsible way, because you don't want people uploading data in the wrong place, and you don't want people building technology that they shouldn't be building. The second is, going back to your point, is that if ultimately those people at the edge are not going to differentiate your business. They're not going to create something in your supply chain that's going to differentiate you from your competitors. So how do you do that? Well, you need to be able to access or leverage deep AI talent. Now, we know that most people have rebranded themselves as AI experts over the past 3 years, and you can come a long way with utilizing those people. But if you want to build differentiated supply chains, then you need to have differentiated talent. So my company, Satalia, that I sold to WPP, had about 120 deep AI experts. We've been building AI solutions for almost 2 decades. We've now grown that to about 400 people. And I know lots of organizations that actually have these incredible talent, but they're hard to attract, they're hard to retain, they're hard to motivate. Often CXOs feel like they can go and build an AI team, and what they're really trying to do is build a career around AI, but it's so hard to attract and retain that talent. So be honest with yourself about that. And then the third is working with partners, third parties that can bring in tools, technologies, capability to help you solve other parts of your organizational challenges. So for me, that really works. You've got innovate at the edge, deep AI talent, and then choosing the right partners.
Makes sense. And one of the things that, you brought to the table as part of that was you brought in the concept of AI agents. And AI agents, I think, people think of AI agents in lots of different sort of fashions as what they do, from, a couple of years ago, what agents were to people and what people perhaps use agents for in their day-to-day life with things like GPT and wider Gemini capabilities, to what really the agentic agents are going to be doing for business. Perhaps you give some concept really on how in 2026 you would describe an agent versus perhaps how you'd have described one perhaps a couple of years ago with the advancements of the technology and the capability that's out there.
So there are multiple definitions of agents, and agents are not a year old. They've been around for a long, long time. My master's project 24 years ago was agents. I created essentially a primordial soup of capability in an environment where intelligence emerged, and we had lots of these agents interacting with each other and learning how to navigate this complex environment. So agents actually are a bit like lazy software, right? If you've got some data, you could build an interface into that data and start using that and accessing that data through an interface. Or you can put an AI on top of it that tries to understand what the data is, and then you talk to the agent to try to then help articulate that data or information in a useful way. So some people think that a wrapper around an LLM talking to data is an agent. Some people think that agents are things that have agency, so they're able to click on websites and to manipulate software and all that kind of stuff to actually do and act in the world and not just regurgitate information or data that it has access to. For me, really, the true power of agents is a concept that's many, many decades old called multi-agent reasoning. So the true power of agents are getting essentially experts to collaborate and communicate to get to an answer greater than some of the parts. Let me kind of geek out a second. There are sort of broadly 4 ways of building an agent or an AI. One is essentially prompting it by asking it better questions. It gives you better answers, but it doesn't have any agency. It's just us answering the question. But it's only going to be bounded by its knowledge. The second way of building a smart AI is giving it context. So in my case, you might give it your brand guidelines, some written copy, some imagery, and you ask that agent to create an ad. And just like in the real world, if you give an intoxicated graduate, which is how I think about agents, that context, they're just going to give you an ad that's 50% good. The third way of making an agent smart is turning that graduate, that intoxicated graduate, into an expert. And we know how long it takes humans to become experts. It takes years of training and trial and error and blood, sweat, tears. In the AI world, there are only some models you can actually tune and train, and that process takes months of iteration and human loop. Again, in WPP, we have a technology called brand brains, and the goal of a brand brain is to produce production grade, differentiated, brand specific content. And again, just like the real world, you create different agents, an agent that's an expert at your written copy, your imagery, or your company values, your brand guidelines, that are able to collaborate and communicate to get to an answer greater than the sum of the parts. So that for me is the true power of an agent, is multi-agent reasoning. And the bad example I often use is if you've got an agent over here that knows that Socrates is a man and another agent over here that knows that all men are mortal, by getting those agents to collaborate and communicate, they're able to infer that Socrates is mortal. They're able to create new knowledge that can be really useful for your business.
Makes sense. So now we've got to this place where we've got the agents and we're putting them in, and it's becoming much easier, and people are perhaps easier to get them in. But actually, what do we need to do then, focused around the governance and controls of those? And this is where we start thinking about agent assurance and the concepts around that.
Yeah. So what's happening, or what's going to happen over the next few years, is that companies are going to unleash an army of intoxicated graduates across their organizations, and forgive the technical term, but it's going to be a shit show, because those graduates, those agents, are not going to be capable of doing their job. They're not going to be experts at solving certain problems. They're not going to be able to actually operate the tools that we want them to operate. And so it is going to go wrong. And actually, in some respects, I welcome that, because I think there needs to be more emphasis, more focus on agent governance, which is, for me, the word governance often is often referred to as being kind of derogatory. That it's a hindrance to innovation. It slows organizations down. For me, governance is making sure that you're focusing your innovation and you're doing it properly. And so if you think about the end-to-end kind of governance process, there's this sort of identification of agents, your agentic needs, and again, some of those can be built by the edge, your employees. Some of them need to be built by deep AI talent. Some of them need to be bought in from third parties. So there's the identification of the agentic needs. There's the sort of triaging of that to different parts of the organization, whether it be a partner or the edge or a deep AI expert. There's the building of the agent. And then there's testing of the agent. And most people might not realize this, but 80% of the energy required to deploy software is testing. But of course, people are going to deploy agents and they're not going to test them. Like the laymen are just not going to spend 80% of the time because it's boring. And so that's why those agents will fail. And then once it's in production, you need to monitor it. And by the way, one big difference between agents and software is agents have the ability to adapt themselves in production. They behave in weird ways, and so you need to then do continuous testing in monitoring and testing to make sure they've not diverged. So agent verification testing is going to be a huge important challenge over the coming years, and we can maybe talk about this later. But I spun out a company from WPP to really lean into this question of how do we do effective agent testing. And once you know what agents are doing, then you need to obviously sunset them and decommission them and all that kind of stuff. But I think one of the biggest challenges that we're going to face is the testing of agents.
Yeah, and I think when we talk about that, it's kind of testing's always been, when the world I come from, where, I guess a system integrator, and my background's all from working in that world. We design, build and implement, IT transformation solutions, which could be complex across a business, whole change program that sits with it. And depending on the industry you work in, the level of testing, goes up and up and up. For example, if you're working in HMRC and you're working on the self-assessment system, you will have performance testing needs, etc., that go to look at that scale of volume. So really, then with the rise of agentic AI, what you're saying is that there is a new testing manifold that's coming in, this agent assurance testing capability, which really is probably the new genre for those people who are developing themselves within that industry.
Yeah, so I guess to getting geek out a little bit, there's sort of two types of testing. There's what is called non-functional testing, which is testing for performance and cost and security and all that kind of stuff. And then there's functional testing. Does this actually have the ability to do its job? Now, there are loads of startups that are appearing that are doing non-functional testing, so red teaming and stuff like that. But to test whether an agent actually has the ability, the knowledge to be able to do its job. So let me give you an example. If you've built an agent that can, let's say, do project management or drive a car, the first thing you're going to do is test for knowledge. Do you know what a stop sign is? Do you know the stopping distance at 30 miles an hour? Or if you're a project manager, do you know Scrum and Agile and the principles of Prince 2, whatever? And now, if you ask that agent, can you manipulate a Gantt chart, it's probably going to say yes, but you need to prove it. So the next level is, how do I put that agent in an environment where it has to use the tools? Show me that you can parallel park. Show me you can 3-point turn. Show me you can emergency stop. Show me you can manipulate a Gantt chart. Show me that you have all of the skills that you need to be able to do your job as a project manager. And then third, I'm now going to put you in sort of real life situations with ambiguous requirements, risk reward trade-offs. You're going to have kids running out into the road. You're going to have bad actors, good actors. I want to see how you're going to perform as an agent doing your job. And the reality is that most people, the way they're testing at the moment is ask a few questions and that's it. So creating simulation environments to be able to then see how software is going to behave is critical. Not only is it critical to understand how software is going to, or agents are going to behave themselves, but you also have what is called nonlinear emergent behavior. If I've now got 10 agents, I have to collaborate with each other. How am I going to actually identify whether those agents are going to collaborate in a way that actually leads to the right outcome? And unfortunately, the only way of testing that is through simulation.
So Daniel, you've developed Conscium as your new entity, your new company. We're still obviously working with Satalia, still working on some of your other programs. We're going to come back to agent assurance in a minute because I want to talk to you about in the context of it. What was the thought process around Conscium? Where did that idea come from, and what is your long-term, if you like, your North Star program with that?
So, ever since I was young, I was interested in intelligence, consciousness. What does it mean to be a human? What's our place in the universe? All that kind of stuff. And that led me doing an undergraduate degree in AI at UCL 27 years ago. There was 2 people on my course back then. Things have changed a lot since then. And my master's was in kind of the emergent intelligence of agents, and my PhD was modeling the brains of bumblebees. And then I realized there was a massive opportunity to apply algorithms to a world to drive value, which then took me on a journey of building enterprise AI solutions for companies using AI, and that company Satalia was acquired by WPP, and it's been an overwhelming success. It's been a fantastic acquisition, and I still am responsible for coordinating AI across now 110,000 people, making sure that we are differentiating our supply chain using agents, using AI, machine learning, large language models, all that kind of stuff. But Satalia, my original company, still continues to build AI solutions. It still continues to build solutions for WPP and clients well beyond marketing. So they're building agents. And as I mentioned, that the acquisition has been very successful. I've become fortunate enough to become financially free, so I get to invest in companies. But I kind of revisited. I think I've been quite good over the past few decades at sort of predicting where technology is going to go, but I've never really capitalized on it as well as I should. I felt actually in some cases I've always been a bit early. I've been talking about AI for a long time, and I sort of thought, well, what's my contribution going to be to the field of AI? So I started to kind of think about kind of where I think the technology was going, what new emerging technologies were coming, and what the implications of that would be. And I sort of realized that there's some interesting technology that's being developed in academia that goes back to my PhD in modeling bumblebee brains, called neuromorphics. And neuromorphics are essentially it's a field which is brain-inspired innovations. Can we look at how biological brains work, and can we then take those innovations and build them into AIs? We know the rhetoric. Large language models require a nuclear power station to run. They require loads of data to learn. They learn very slowly. They are crude representations of our brain. They are getting smarter, and I actually argue that they are now graduating from intoxicated graduates to a master's to soon PhD, and eventually we'll have a postdoc, and maybe by the end of this decade we'll have a professor in our pocket. But these are crude representations of our brain, and the reality is that your brain operates on the power of a light bulb, and you don't need a nuclear power station to run it. So there are many innovations that are coming out of academia that are modeled on how biological brains work that are going to inspire the next generation of AI. And rather than waiting for that to happen, I should have bought NVIDIA stock 20 years ago, but rather than waiting for that to happen, I've now invested in the development of neuromorphics with the North Star of understanding whether it's possible to build conscious AI. So that sort of expanded a little bit, which is it possible to build conscious AI? Should we build conscious AI if we can build conscious AI? And then would a conscious superintelligence be safer for humanity than a zombie superintelligence? At the moment, we are building a zombie superintelligence that will be hell-bent on achieving its goal without feeling, without empathizing, without understanding what pain and suffering and love is. So the question, the North Star is would a conscious superintelligence be safer for humanity than not? And so we're backing and investing in the development of neuromorphic technologies, which are significantly more energy efficient, significantly more adaptable. I think are going to be the next generation of AI. But if you are building AIs, then you need to test for them. You need to test, does this have the skills, capability? Is it conscious, for example? And so rather than having this verification capability just servicing our needs, we realize there's going to be a massive opportunity for verification way beyond Conscium, way beyond WPP. So Verify AX, which is our first product, which is actually launching in 2 weeks, which has taken 2 years to build, is going to be launching in 2 weeks, and that will be able to verify any agent for any capability. And eventually we'll be using it to verify whether agents are conscious.
So I'll come back to Verify AX in a minute, but I want to ask you a quick question about consciousness, because our CEO asked me to ask you a specific question. So I'm just going to pull this question up. I'm going to read this one because it's quite a long question, so bear with me. So David Eagleman, among others, stated that the subconscious mind is responsible for 70% of all our daily decisions and actions we take. Is Conscium conscious AI research embracing human subconscious decision-making for AI, or is that a later development?
Oh, Lee always asks hard questions. So I guess when you ask people what is consciousness, they will refer to certain features like language, or it's my inner monologue or dialogue. By the way, I don't have an inner dialogue. I think you know that there's a concept called anandaphasia, which is there are some people that just have no inner voice. And I didn't realize that until my 30s. And actually, I've written an article I'm going to be launching recently explaining why actually having no inner voice maybe has helped me appreciate consciousness in a different way. But if you ask people what is consciousness or intelligence, often they confuse the two. They confuse intelligence and consciousness. And often they refer to human level consciousness. And the fact is that there is different types of intelligence and consciousness way before we get to humans. But if you ask people what it is, they usually refer to things like language, your inner voice, your ability to do long-term planning, your ability to know that you're a self in the world, the ability to empathize, to feel, to take this light that's going into your eyes and constructing an accurate model of the world. And what's interesting is if you take those different features and map them to my favorite definition of intelligence. And by the way, most people's definition of intelligence, I think, is weak, which is getting computers to do things that humans can do. It's a popular definition, I think, is the weakest definition. But there's a very elegant definition of intelligence from the 1980s, which is goal-directed adaptive behavior. And what you're essentially have evolved over the past hundreds of millions of years are features that allow you to make predictions, and then features to allow you to then see whether those predictions were good or bad, and essentially adapt to a rapidly changing world. And I actually argue that if you imagine each one of these features is like a segment on a color wheel. Now, arguably, my language ability is hopefully greater than a bumblebee's, and my ability to do long-term planning is probably greater than a wolf's. But imagine you've got each one of these segments on a color wheel. When you put the color wheel into motion, what happens if you have all the colors? Then white emerges from that. And it's a bad analogy, but the argument in some consciousness research is that consciousness is an emergent property of the interaction of all of these different things that are going on. When you stop it and try and look for consciousness, it disappears. So actually, I think I've got my head around consciousness now. But going back to Lee's question, my therapist argues that 95% of the stuff that goes in your brain is your unconscious, and what happens is that then your unconscious then surfaces that into the conscious part of the brain, then you sort of reason with it and use language and all that kind of stuff, and then it comes out of your mouth. I actually don't have that bit, so arguably I'm not conscious at all. But so is Conscium looking at that? Absolutely. And actually, one might argue that certain AIs are already unconscious. They already do processing without any awareness, without any feeling. 67%, by the way, of the population currently believe that large language models are conscious, and they're building relationships with them and things like that. And the reality, again, there's no very good definition of unconscious, which is why we've invested in trying to pioneer some of this thinking. But to answer Lee's question, we're trying to understand biological brains, and we're trying to understand thresholds of intelligence and self-awareness, feeling, suffering, and emotion.
Amazing.
Yep.
So if we think, if we move on from there, you mentioned a short while ago Verify AX, which is your first capability product service that's been launched through the Conscium brand. Something obviously with an Exponential-e we're looking to partner with and looking at how we can adapt that into our customer base. Why don't you give me a bit of a view of Verify AX as a capability? And we talked also historically in the session about agent assurance. Obviously, this is the adaptability part about driving that within organizations. But what do you feel is the sort of advancement that you've made in that space with the technology you've put together? Yeah.
So when you submit an agent and you give it its kind of description of what you want the agent to do, what we've done is we've managed to, and this has taken 2 years, to be able to use AI, different types of AIs, essentially AIs that have been trained in creating tests, to come up with different scenarios that we think will do a good way of covering the test coverage of testing that agent. Now, we know it won't be 100%. We know that it's probably somewhere between 70 and 90%, but we can use AI to get you a long way in terms of creating that test coverage. We can also, going back to this idea of multi-agent reasoning, we can use these tests AIs to collaborate with each other to come up with tests that no one AI can do by itself, which is important because people might think, well, I can go and do this myself just by having, ChatGPT test my agent. But the reality is that you need a complex set of experts that are able to, again, collaborate and communicate to come up with tests that you wouldn't be able to get one AI to do. Well, we also are allowing people to crowdsource tests. So if you go and build an agent that you want to play chess, well, it's easy to come up with those tests. Those tests are available on the internet. But if you want your agent to be able to do audit, in a certain way that is, domain specific to your practice, then you need to give it context. And so human beings we are allowing human beings to actually come up with tests that we know AIs are probably going to struggle coming up with, and we're going to be also making those tests available on a marketplace. So if you're coming up with very specialist audit tests, you can then make them available to other auditors. So you're crowdsourcing tests. I think there's actually a future where people are paid to create tests that AIs can't come up with.
That's really interesting. Yeah. And going back to the sector specific piece, because a question I always get asked, and have to talk to organizations about in this space is, so we take it, we build our agents. Our agentic agents are built around our business, our life cycle. So whilst obviously there's commonality in the thing that they're doing, for example, a tax process or something, there is the customization that to do with their business, their process. So they might have historically been doing some level of robotic process automation, and then this becomes an evolution with agentic capabilities and the AI built into it to learn better, be faster, be quicker, and do all of those things, and adapted to replacing perhaps functional parts from different departments where, as you say, agents talking to agents, responding and talking. What level of, you deploy Verify X into their environment, for example, you connect it into their systems. What level of typically customization do you do in the first instance to work with an organization to get it there? Or is it just plug and play, off you go?
In some cases, it's plug and play. So even where an agent has to be tested to be able to do a certain workflow, you can submit your agent and then you can submit your context, and our testing expert agents will be able to look at that workflow and say, okay, we need to test it. You can actually go through this workflow. You don't have to do that yourself. So that's where a lot of the complexity has been built to make that as seamless as possible. Again, there will be some cases where human beings have to create those tests, but we've automated as much as possible. We continue to automate it.
And then as you get into it, so you've got that going, this is where we move in the same way that development has moved into a new world, a DevOps and functional and SecOps integration for that continuous development. That's going to be happening in the agents. So the agents are now in that world. So then with the Verify and the agent assurance piece, does that move into the same circular model that it's just, instead of the human-centric testing that was perhaps built into that or not done at all, or, as you said, the red-black testing, whatever it may be, are you now moving into that new model where this is ingrained within the workflow of everything they do forever?
Yeah, exactly. So it's always on testing. And so as I mentioned to you earlier, that if you go back to this idea that you let people to innovate at the edge, so people are building agents, there needs to be a mechanism for them to say test, and it's green, we can deploy it. There's people that are specialists in building complex, deep agents that will be going to the verification platform and building complex tests and all that kind of stuff. And then there'll be tools like ServiceNow and Workday where people will be able to build agents in those tools, but they'll also be part of that process as having to test it. And then also there's continuous testing. So you don't just test for security once, you have to continuously monitor for security. And actually, it's still very nascent in AI research to understand when should you trigger a test. Should you wait for a certain period of time? Should you look at how its training has changed in a certain way for it to, or do you just do constant testing? So we're going to go from 80% testing of software to 99.9% testing of software.
Yeah. So if we evolve on from there, we're now in this situation where you've got this continuous development, which is great because it's making us more agile, faster, quicker, adapting our capabilities. Yep. We've integrated this now for the agent assurance, but we've now got a situation where we've got AI on AI to a level because of the autonomous nature of the testing. Yep. One of the things the agent assurance is there to do is to create those guardrails, create those metrics to avoid hallucination, to create those security controls if we're deploying it in the context of the security aspects that sit around it. At that point, there must be the sort of the check and balance of the AI that's checking the AI. What's the concept and the vision around that?
Yeah, so in some cases you get pretty confident. If you've run a scenario multiple times, you get a confidence level that this it can do its job. There is a whole other field of verification called formal verification, which is not just simulating things to see what happens, but being able to formally prove that this thing will never reach a state that you don't want it to reach. Now, again, this research is very nascent at the moment, but we're leaning into how to do this ourselves. At the moment, the best mechanism is to create simulations of agents that you trust are really good at coming up with tests and testing those AIs. And again, we provide a rich set of information in terms of how performant it's been, how much it would have cost you if you had to run this yourself versus on our infrastructure, how much time you've saved, all that kind of stuff. We provide a rich set of information in terms of the quality of those agents. We give it full transparency in terms of what conversations the agents had, and also we provide people with advice in terms of what do you need to change to make your agents perform better. There are scenarios where interestingly, you have one LLM, I won't say which, that's trying to orchestrate a team of other LLMs that are from a different organization, and it doesn't do a very good job. Whereas you flip them, if you have this other organization's LLM trying to coordinate these other LLMs from a different organization, it performs much better. So we're getting all of that knowledge, and then we can not only provide verification advice back to our clients, but we can also provide, here's actually how you architect your agentic systems better.
Brilliant. So I'm kind of going into these sort of complex environments, right? So suddenly we get involved a little bit further. So suddenly we're into a position, to your point, where we've got hundreds, if not thousands, of agents. These agents are performing functions that we've migrated from traditional ways of operating into these new ways of operating. We've integrated this testing manifold that sits around it. Part of the testing we're doing is to avoid things like hallucination. Part of it is to looking at drift, those kind of things that we're looking at. The tool sets from Verify AX, for example, the visualization outputs, is that where it's picking up on those pieces and demonstrating to the people where that's happening? And is the vision to put preventative steps in there, or alerts or flags for those things to highlight them quickly? What's the sort of thought process around that?
Exactly. We should show you a demo. I think the reason why people love it is, first of all, from a developer perspective, it just takes all of that worry about coming up with your own test cases. I mean, you should be coming up with your own test cases, but it just takes that worry off your table. You can now outsource a large majority of testing to a service that can do it more effectively, cheaper, faster, more coverage than you can. But what managers love and decision makers is the rich amount of information that you get back in understanding where your agents are performant, where they're not performant, what you can do to improve them. So it just gives you confidence. And one day we might even have that as part of the scorecard that every agent carries around with them. So it says, this is my job, and by the way, just like your CV, this is what I'm good at and what I'm not good at, which I think is an exciting future. And actually, one of the things that I wasn't going to talk about, but I will. But obviously, we've all heard of things like A2A and MCP, these protocols for us to interact with data and with agents. One of the things that we're working on is an AVP, Agent Verification Protocol. So one standard methodology for you to be able to write a test case for an agent and get an output. And whilst that would make it easier for people to port their agents from our systems to somebody else's system, we think this is so important, and we need to make sure that the systems are interoperable. And so if you've built some tests, for example, on Verify AX, you could easily then port those tests to another system, or vice versa. Testing is going to become so important over the coming years that we just want to help make sure the community are leaning into it in the right way.
Yeah, that makes complete sense, which kind of leads perhaps on to one of my last questions, which is, everybody's now accelerating this work and activity in the sort of agents, agentic capabilities, however you want to position it. What do you perceive? We see some perceived challenges at Exponential-e really in relation to making them portable. And there's a couple of dynamics around that. One is, obviously, it's very easy to very quickly get very proprietary around a particular technology. The simplicity in the hyperscalers of accessibility to systems technology products, but they're not necessarily overly portable in relation to that. That's one challenge. Also, we're seeing, and I'm sure you've noticed, there's an increased conversation in particular in Europe around sovereignty happening, with people taking stuff out of certain types of organizations and putting them into different frameworks and models. And I think that also comes naturally with the geopolitical and sort of the challenges we have internationally at the moment, that people are seeing the risk factors potentially around that. What would be your advice around this for organizations? So we heard the advice from you around making sure you've got the assurance piece wrapped in as your core foundation model. What about when they're building out? What advice would you give them around that in relation to protecting their business but driving the value from AI?
Yeah. I mean, I can tell you how we've been doing it. So we've ensured that we're not dependent upon any models. And the reality is that even when there's a challenge of when you upgrade a model, will it behave in the same way? But even models that haven't been upgraded behave differently every time you engage with them. So you don't even, it's not even about portability. It's actually just, if you ask it the same question in a week's time, it might behave differently. So we've spent a lot of time ensuring that we are actually more likely, we use open source models for the most part, because we've got control over them, and we also make them portable. So if you wanted to kind of move your infrastructure away from one cloud provider to a proprietary cloud, we make that as easy as possible. And there is a growing concern around data sovereignty, AI sovereignty, model sovereignty, all that kind of stuff. So the more fluid you enable your infrastructure, the more portable you make your infrastructure, the more protected you're going to be. So we designed Verify X in a way that can be cloud agnostic, model agnostic, and also can run on a proprietary infrastructure. And we think that most organizations where it's really, where it can materially impact your business, if that stopped working, then you need to probably think about making sure that it's protected.
Okay, thank you very much. And perhaps my Columbo moment, you always have that last question, one last question before he walks out the door. You talked about neuromorphic AI being the future. We hear about other advancements in technology, speed for them to happen. And then we see, obviously, you mentioned NVIDIA before, and obviously their focus, we've got GTC coming up very shortly. They're going to obviously put on their big announcements that sit within that. But the reality is there are big, I guess, power cooling challenges associated with that. Liquid cooled data centers to power the latest GPUs, for example, the volume of power that's available, the sovereign aspects that sit around that. How far away are we from seeing these advancements, do you think, that drop down that sort of computational horsepower need and start shrinking it down? And I think that, neuromorphic is one of the things that attempts to do that, right?
Yeah, I think we're sitting on probably one of the most powerful neuromorphic foundational models in the world. We just published a paper last year with Yoshua Bengio and some of our team, and that model is actually being used in a project that we've just won to do drug discovery. So you can train these very energy efficient models, adaptive models, on very specific domains and have them operate much more effectively than large language models. So small language models are starting to become a thing because they're cheaper to run, all that kind of stuff. But neuromorphics takes that to a different level. It allows you to run them, again, hundreds, thousands of times more energy efficient, and it allows them to adapt very, very quickly to a changing environment. So I think that the exciting thing is there are many innovations that our brain does that will allow us to build much more adaptive AIs. I don't think companies like NVIDIA will be placing bets on all of them. So we've placed a bet on a handful of innovations that we think are exciting. But who knows? I think in the next few years we're going to see more of these types of neuromorphic technologies appearing.
So Daniel, thanks so much for coming and taking the time to speak to us today. I think it's been really good to listen to this, and it's certainly got my brain thinking about 100 more things and ideas that come with it.